Hi everyone, I'm Zensong from WebDenial team. Today I will walk you through our secure blogging platform project. Here's our agenda. We will cover the project background, security goals, and user journal with implementations, potential attack we identified, and our hardened security mechanism. WebDenial is a secure blogging platform that applies defense-in-deep strategy. We built it to bridge theoretical security concept from lecture with real-world defense programming. Our authentication layer supports user registration, login, logout, plus a separate admin authentication system with internal only admin registration. For the content management, user can create, edit, delete posts, view the latest posts, and manage their profile. We implemented role-based access control with two rules: regular user who can only manage their own content, and admin who have full control over all posts and users. We also have an audio log-in system that traces all critical action, an admin dashboard to review logs, and dynamic rate limits to defend against DDoS attack. For the confidentiality, only authorized user can access data. Credential and sessions token are never exposed or stored in plain text. For the integrity, data can only be modified by authorized principal, audio logs are immutable, and all changes are traceable. No anomalous modification allowed. For availability, the system remains usable under normal load and degrades gracefully under stress, first to read-only mode, and then to read limit access. For the security matrix, our confidential matrix targets 0 unauthorized data access attempt and 0 unauthorized audit log access. For the integrity matrix targets 0 data tampering, 0 anomalous change, and 0 audit log modification. For availability, we target less than 1 second downtime and under 3% of request failure rates. Here's how to get started. Install dependence, initialize dataset, and create an admin account through our secure command line, not through the web interface, and run the application on localhost. On the user side, users authenticate with enhanced security measures. They can create and manage their own posts through the clean interface. Admin has access to users' management and the system monitoring and the audit log review to keep the platform secure and well-governed. We identify several attack vectors. First, authenticate vulnerability. Hardcode admin credential in source code will give attackers instant admin access. Second, cookie forgeries. Use a plaintext user ID cookie means that attacker could simply change the cookie value to get the privilege. And system misconfiguration was another risk. Running Flask with a debug mode expose the debugger. Attackers can crack the debugger pin using the machine-specific information. We also find abuse vulnerability, like the CSRF attack could force the login users to unknown delay post. Without relimit, brute force attack can crack the password after trying like 100 times. Here's our strategy to harden the security. We remove hardcode credentials and create a command like the terminal lines only admin setup. We add anti-brute for protection. It's like the within the certain time that user can only try for several times. If it fails, then it will be locked. For the session management, we replace the plaintext cookie with the server-side sessions. We generate like this 64 characters random hex token, store them in the database with expiration time, and validate against the server rather than trust the client cookie. For infrastructure protection, we disable debug mode in production to eliminate the RCE risk. And we implemented CSRF protection using the debug using the double submit cookie patterns. Requests without matching tokens are rejected with HTTP 400. Here's the takeaway and lessons we learned. The first is that the default setting like the admin credential and debug mode are hidden risk. The second is that the weak session management can break your entire security model. And the third is that strong security does involve usable trace trade-off, and real attacks are surprisingly simple. The small oversight becomes a critical vulnerable. Yeah, let's conclude our presentation. Thank you for your attention.